Hello, class. I'm here to talk about problem 9 of chapter 3. By now, I hope you watched problem 7, which gives you the basics of the sensitivity analysis report. I might have made a mistake, not a mistake, but I might have reversed these values. Always the decrease, the allowable decrease, that means what you subtract from your actual value right hand side value or these values over here, which are the same as this one. So your allowable decrease should come first and then the allowable increase. Okay, which it tells you right here that as long as we stay in this range, the dual value will remain the same. Otherwise, they call this the range of feasibility. Otherwise, once you're out of this range, any of these ranges for this constraint 1, constraint 2, constraint 3, then your dual values are not going to be reliable, and therefore you would have to develop a new LP linear programming. And you should know by now that working on a linear programming can be time consuming. If you have work on problems for chapter 2 where you have to do everything from the beginning, including to graph everything, get your corner point where it would give you your optimal value, what is binding, what is not binding, and give all this information, you do know that takes time. Therefore, the sensitivity analysis tell us what if I change this coefficient right here? What if I change the right hand side over here? What if I change the coefficients for the objective function? What would happen if these scenarios would change? If you notice that a mistake was made, it wasn't supposed to be 80,000, it's supposed to be 79,000, for example, or if right here you say no, 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 really we should do, instead of 3 shares of the US oil, we should do 2 shares. How would that affect? So right here on this sensitivity analysis report, it tells you how much you could go ahead and make this change without affecting your optimal value. Okay, you have to remember the optimal value is composed of two sides. You have your coefficients on the left side and you have the actual optimal value. You have to also understand that if I do change, for example, your coefficients right here for your objective function, you will change your value over here. Okay, so I'm not saying it's not going to change if you use the allowable decrease and increase. It tells you how much you could make that change and stay on right here on the range of feasibility, or stay on the range of optimality, sorry, which I have included on problem 9 here. So let's go and start problem 9. Problem 9 is talking about salsa. It's talking about Western food salsa, if I'm not mistaken, Mexico City salsa, which they have abbreviated as the variables W and M. Okay, so when done all the calculations for you, a solver or whatever software they would be using has defined that the idea right here would be to produce 560 jars of Western food salsa and 240 of Mexico City salsa to get a maximum profit of 860. Okay, so which gives us already the answer for the first one right here for letter A. So remember that right here you're always going to find what are the optimal values for your objective function or your coefficients right here, and over here you're going to find the actual value, the optimal objective value. Once you calculated this, how much would you get? Right here in this problem, if you go to your textbook, you know that you're talking about profit. Therefore, this is dollar amount. And if you also remember from problem 7, once you have this as a dollar amount, you also have your dual values as dollar amounts. So right here, these are cents, 12.5 cents, 0 cents, and 18.75 cents. Okay, so we're talking here about money. So let's go ahead and start with problem A. I believe I put some notes pretty much saying that the sensitivity analysis report tells you when chains are enough that we don't need to develop a new linear programming. So how much? Because once you go out of this range of feasibility or your range of optimality, then you definitely need a linear programming to have your correct amounts. And also, what is the effect of the change? So if you change this value right here for constraint one, how much would be the change? If you would increase 12.5 cents and then you decrease 12.5 cents. What about this? And then it also tells you about the binding constraints. Remember, the every value with is like a zero, those are binding constraints. So just by looking here, I can say that constraint 1 and 3 are binding, constraint 2 is not binding. Okay, so it is really not gonna change, it's not gonna increase or decrease if we change the constraint number two. And then we're gonna go over the rest. Okay, so let's start with letter A. What is the optimal solution and what are the optimal production quantities? So according to this, you could say your optimal solution is 560 jars of Western salsa and 240 of Mexico City salsa, and they're gonna make $860 with that. They're gonna make a profit. If we have one jar at $1 for 560 jars and $1.25 for 240 jars, then the profit would be 860. To confirm that, we can go ahead and do 560 jars times 1 plus um, 240 should be the other way, but this works 2 times 125, and you're gonna get 860, which confirm our values are correct. Now specify the objective function range. Is specifically talking about your range, but if you notice, is also talking about your objective function, not your constraints. Therefore, if we go down your sensitivity analysis report right here, so if you know you have a dollar for Western and $1.25, if you look over here, your objective coefficients for Western is $1 and for Mexico is 125. And then they are asking you a range, right? Therefore, we're going to look at these values. How much can we decrease and how much can we increase? Just note that I'm not saying that this value is not going to change. Definitely, if you change, for example, if you have an allowable increase of 25 cents and you decide to go with that, and instead of a dollar now is a dollar 25, well, if you multiply the dollar 25 by the 560, it's not going to be 560, it's going to be higher, and therefore it's going to change this value right here. So it's just change telling you how much you can change without having to develop a whole new linear programming, because then you wouldn't have reliable results. So right here for your range, you're gonna have a dollar, and then your decrease, we always go do the negative first. Your decrease of 10 cents, 10.71 cents. So we're gonna do 1 minus 10.714. So you can go to 89 cents without without compromising the whole problem and the whole report. Okay, you will change your value, but if your manager wants to know, okay, and if I would decrease, because I'm really want to sell some more jars, do you think if we decrease to 89 or 90 cents, how much would I be losing here? Can you tell me? Uh, but then, I might be selling more now. Therefore, how much am I going to make? So that's why we have these ranges. So for your increase, you have one for your coefficients, a dollar plus 1.25. So you can go from 0.89 all the way to 1.25. This is your range, okay? And then for the second one, $1.25, you can decrease 20 up to or down to 25 cents and up to 15 cents. Therefore, 1.25 minus, let's do the decrease first. So I'm doing $1.25 minus allowable decrease, 25 cents. And now I'm gonna do $1.25 plus 15 cents because that's the increase. So now you have that my range for my Mexico City salsa should be between 1 and 1.15. Okay, so this would be your answer for problem B. Maybe I can go ahead and put there. Let me put it over here. Even though when I give you the templates, I'm not going to have those results. I just want you to see where it goes. Oh, I copied the same one, didn't I? Oh, let me go back again. Here we go. So stop that one, copy this one, and right here. Okay, so now this are my objective function range. This is gonna be for Western salsa, and this is gonna be for Mexico City salsa. But what does this really mean? What I just said, that this value will change, but as long as you stay in this range, you're fine. Once you are over this range, either on the negative side or on the left side or the right side, then I'm not responsible for any of the results. Then I would have to develop a whole new linear programming and a new sensitivity analysis report in order to give these values and be reliable values. Okay. So now, what are the dual values for each constraint? Well, if you do remember from the other problem that we did, problem 7, these are my dual values, and it says that for every 1 unit change in the right-hand side, over here, value of a given constraint, the dual value tells us how much change there will be in the objective function on this value right here, okay? So, which I have typed here before to make this video a little faster, but just by looking at it here, I have typed in over here for you to constraint 1, constraint 2, constraint 3, which is this 3 right here, right? Actually, let me go down here. Yeah, which is this 3 right here. And then this is my right hand side. So it's saying that if I increase this by 1, I increase this value by 12.5 cents. Remember, these are dollar amounts. And then for the second one, if I increase by 1, I'm going to increase by nothing. Do you see there's 0? And on the third one, if I increase by 1, I'm going to increase by 18.75 cents. In the same thing, which I should always start with that, the decrease. If I decrease this value by 1, the right hand side, right here, right hand side, if I decrease by 1, I decrease by 12.5 cents. And then the second constraint, if I decrease by 1, there's no decrease because you have a surplus. And then if I decrease by 1 here, you have a decrease of 18.75, which I already typed in here. If you would, not if you would, you were going to have to tell me what does that mean. So you can say right here, for each tomato above, for 4,480 will increase profit by, in this case would be 12.5 cents. Or you can say, actually is they're talking about ounces, so we can say 1 more ounce of whole tomatoes, oops, will increase profits by, and then you can do, which is 12 cents, 12.5 cents. Same thing over here, which I had put it before. So right here on this one that it has a 0 dual value, we can say that additional ounces of tomato sauce, and I'm going by here. Here's whole tomatoes, tomato sauce, tomato paste, will not improve profits. Okay. And then the last one, we can say that for each ounce of tomato paste, which is the third constraint, above 1600, the right hand side will increase profit by 0.1875. Or you can also say one more oh, ounce of tomato paste will increase, oops, profits by 0.1875 or 18.75 cents. And then you would be done with problem A, B, and C. Remember, right here is only asking you for the ranges, but if I would ask on your final for a definition, you have to tell me that as long as you stay with these ranges, you don't have to develop a new LP, or as long as you stay with these ranges, the report is reliable. There are several other reasons that you can give. And then the last one we just answer, which is right here. And then the last one, we're going to identify each of the right-hand side ranges. Well, if we're going to identify each of the right-hand side, then we are talking about right here on your constraints, okay? The right-hand side range. Well, right here they give you the actual values, right? They're just bringing from here 4480, 2080, 1600. 4480, 2080, 1600, and then they're giving you how much you can decrease and how much you can increase. Therefore, what we need to do to have, which we call the range of feasibility, is that means as long as we stay in this range, then our dual value will work. So all we need to do is to do the actual right hand side value, which is 1448 minus how much is my decrease? 160. And then for the right side, not right side of, if you have any in a parenthesis for a range, please don't get confused, is going to be your value, right? The value of your constraint plus, because now we're doing the increase, 120. Allowable increase, allowable decrease. So I'm doing this first constraint, and I did 4480 minus 160, and then I did 4480 plus 1120 since it's an increase and a decrease. Now I'm going to do the same thing for the second one, which is 2080, correct? Minus a decrease of 160. And then now, well, really, if we have an infinite, then we can just go ahead and we know it's an infinite value. We can just go ahead and include the symbol infinite right here. Okay. And then for the last one, we have a value of 1600 minus my decrease, 1600 for constraint 3, my decrease are 320, right? And then we have an increase of 40. So 160 plus 40. Therefore, these are my range right here. And you can go ahead and put them in parentheses if you want, because that's what it would define my actual range. I'm just going to type infinite to be faster. And right here, I'm going to move this over here. And I'm going to say 2080, 1640. And this will be the answer. Okay. So as long as you stay with this range, these dual values will work just fine. Once we go outside the range, then we need a new linear programming.